surround sound speakers, consisting of multiple parts that can be mounted together with glue and screws. One interesting difference, however, is that its entire perimeter walls are to be filled with our special plaster of Paris mixture, as the whole unit will be dedicated to mid-tone use without its own built-in subwoofer. This is because we're going to be sending these subwoofer frequencies to the two front surround sound speakers adjacent to it, which is a really efficient way of mixing it into the track. Again, after the usual finishing process, this makes for quite a nice enclosure, with the mid-tone driver taking centre stage. One thing though that you might be wondering is, where's the tweeter? Well, the idea is to have the tweeter mounted to its own little chamber on top. This isn't just an aesthetic choice, although it does look pretty cool, but is primarily a decision to keep the tweeter time aligned with the mid-tone driver. You see, on many centre channels, the tweeter sits between two mid-tone woofers. Not a problem if you're sitting directly in front of it, but if anyone else is off axis, they can be left in an interference trough, where important vocal frequencies dip in volume significantly. This happens because of the slight horizontal distance between the tweeter and woofers, which means that the sound waves from them won't always land at the listener at the same moment from an off-axis listening position, causing them to cancel out. This is why I've decided to have the tweeter mounted above the mid-tone driver, because it doesn't matter how far off axis you are, the sound from either speaker will arrive at you at the same moment, avoiding the interference trough. So either way, we have now got our centre channel, and it's time to add the laser distribution system to it so that we can beam audio to our surround sound speakers. As you might expect, this is going to be based entirely around some small, cheap, analog to digital SP-DIF Toslink converters. By soldering 4 of them up to a little terminal block, we essentially have a 4-channel laser distribution system, with the lasers sitting snugly in the 3D print. Before we can mount it in place though, we do need to do a bit of prep work on the centre channel. You see, these Toslink converters don't do any amplification. That needs to be handled by a separate amplifier. The one I have here can sit within the chamber on the back, and be screwed in place and wired up to the speakers. To ensure that each speaker receives only the frequencies that they're best at reproducing, we'll be passing the signals through a little digital signal processor. This will allow us to program different response curves and frequency shelves to optimize for each driver, squeezing even more performance out of them. This too can be mounted onto its own block next to the amplifier and wired up to it, leaving one last area for the laser distribution block, which likewise can be mounted in place and wired up. All of these wires and circuit boards do of course look quite messy, but that's okay, as the intention is to cover them up with some back panels. As you can see, all of the connectors for the signal inputs have been angled downwards, and this saves a lot of space, as the intention is to actually have this centre channel speaker mounted on some wall brackets above a TV, as this keeps it nicely out of the way, far away from the floor, in a good position to be heard clearly. Plugging in its power, we can see that the lasers are successfully firing at the ceiling. Now, these upward-firing lasers might seem like a bit of an odd design choice, seeing as we need the speakers around the room and not on the ceiling, but the idea is to actually use some little articulating mirrors to bounce the lasers to where we need them. These have been made from a few 3D printed parts, and as they can be adjusted in rotation and mirror angle, we can use them to direct the lasers wherever we want in a room, using more mirrors at the other end to bounce the lasers back down towards the speakers. The beauty of this is that the lasers are kept out of the way along the ceiling, so that their line of sight can never be broken by people walking in front of them, nor any of the alignments disturbed. It's a set it and forget it configuration, and it really is the only way that this wireless system makes any sense. So now that we have our lasers dotted around the room to approximately where we want our speakers to be, we need to enable the speakers to be able to decode the audio signal contained within. This, of course, is where the SP-DIF Toslink receivers come into play, just like the standalone bookshelf demonstration earlier. Instead of going directly to an amplifier though, we'll be following the signal path with another digital signal processor, so that we can make sure that each of the 3 drivers within the surround sound units can get an optimized audio signal, which is particularly important for their built-in subwoofers. A perfect spot to mount these is the rear chamber on the back, where the space for the same style of amplifier we used for the centre channel. Just like there, this powers each driver independently, receiving its input from the digital signal processor, which, as you can see, has been mounted onto a back panel. This allows the whole thing to be neatly closed up, with the Toslink receiver facing upwards on the back, ready to receive its laser signal. Having already set these up, our new wireless surround sound units can simply be slid in position so that the lasers hit the Toslink receivers, providing each one with lossless, lag-free audio that literally operates at light speed. Being powered speakers, they do of course need to be plugged into a wall socket, so they're not 100% wireless, but that's fine by me, as there are usually plenty of these to choose from around a room. Now, to get a surround sound signal to the centre channel for it to then redistribute to the other speakers, we're going to be using one of these little surround sound extraction boxes. These are very low cost compared to a normal AV receiver, so are a perfect choice that plays a part in keeping the overall system cost down. You can use them to extract uncompressed surround sound from an HDMI connection, allowing the speakers to have uncompressed audio end to end, which is pretty neat for a wireless system. From my testing, it performs brilliantly. The audio is crisp and sharp and in sync with the TV's image, and the bass is sublime. The fact that each of the surround channels go down flat to 35 Hz without requiring a separate subwoofer makes the soundstage really enveloping, and it's so cinematic. And the surround sound effect you get from the rear channels at the back of the room really contributes as well. Now, the best bit is that using brand new parts, this entire setup costs about the same as a mid-range soundbar, which is incredibly good value for any surround sound speaker set, yet alone one that works wirelessly with zero latency and no compression. Pretty cool. Now, I can hear some of you saying that, Matt, humans can hear down to 20 Hz. 35 Hz just isn't going to cut it for a cinematic experience. Well, I've got you covered. Now, this is somewhat experimental, but according to my calculations, we can use a 3-meter long PVC pipe to hit these low notes using another transmission line configuration. Now, of course, as this is so long, we do need to trim it down into sections. This makes its size much more manageable, and to join it back up again, we can simply use some more 3D printed parts. As the plan is to use 2 TCP115 drivers coupled together with it, there'll be a lot of air movement to contend with, so it too needs a flared exit port to reduce chuffing noises, just like on the main surround sound speakers. Now, this is admittedly incredibly ugly, which is why it's to be considered a bonus rather than a completed project item, but as it's slim enough to slide behind a TV, it can't be seen anyway, so it doesn't matter too much. Now, the amplifier used in the centre channel speaker has 2 spare channels, so these can be used to power each individual driver with the appropriate subwoofer frequencies. Right now it's playing a 25 Hz test tone. You probably need headphones to hear it at all, but it's really deep. It feels like there's a standing wave from a car outside or something. It's kind of crazy. You can feel it in your chest. That's wild. We got snowmen! It was literally a childhood dream of mine to make a proper surround sound system, so to have made one that sounds so good and works wirelessly using lasers is a pretty good feeling. Don't forget that if you'd like to build a set of these speakers for yourself, you can find the printable files for them in the video's description, along with a link to the LTT ratcheting screwdriver if you'd like to buy one to help you construct them. But other than that, I'm Matt.